So today we are going to learn how to transform quadratic functions. We've already seen how to transform linear functions. When we covered linear functions, we either reflected the linear function, we translated, and we rotated. So we slid, we flipped, and we turned. Today we are going to transform our parabolas. We are going to learn how to flip them up and down. And we've already seen that by the sign in front of the x squared term or our a term. Remember, when it's positive, it's up. When it was negative, it was down. We're also going to see how we're going to slide them or translate them. And then we're also going to look at making our graphs narrower or wider. So here, they're asking us for each quadratic function, find the axis of symmetry, the vertex, and state whether the function opens upward or downward. This is exactly what we did on yesterday's quiz. Remember, to find the axis of symmetry, you are going to use the formula negative b, or opposite of b, over 2 times a. Remember, it's always an equation. It's always a line of symmetry. So here we're going to look at our first number 1. We can see that a is 1 and b, there isn't 1. Okay, so it's b equals 0. So now I'm going to plug these two numbers into my equation. So 0 over 2 times 1, anything divided by 0 is 0. So my axis of symmetry here is 0. And then to determine if your graph opens upward or downward, you are going to look at the number in front of x squared. It doesn't have a number, so I assume that there's a 1 there. So I can see it's positive 1, so I know that it opens upward. So this is just a quick review. It's exactly what you did on yesterday's quiz. So our objective here is going to be to graph and transform our quadratic functions. So back in lesson 810, we talked about 510, let's see. We talked about transforming linear functions, and everything was compared to the y equals x. So remember, when we had linear functions, if the y-intercept changed, that was the translation. If the sign in front, so say it was y equals 2x, and you were comparing it to negative 2x, this would be a reflection. And then when the number in front of x got larger or smaller, that was the rotation. So this was a review. Now we transform our parabolas. Now, when we're comparing, we're always going to compare to the parent function, which is f of x equals x squared. Again, remember, f of x is a fancy way of saying y equals. And again, so we can tell which one's different, because when you're taking the test or the quiz, it's going to be in black and white. But when we see this in the notes, we can actually color code the different graphs. So the reason why they're going to introduce the function notation is so we can tell the difference between the two functions. So for our parent function, and this is going to be the main one that we're going to compare all the other ones to, it's going to be f of x equals x squared. Notice our axis of symmetry is 0. The vertex is at 0, 0, and it only has 1 0, and it actually happens to be the vertex. Okay, now here is where we're going to start comparing. We're going to see what is different between the 3 functions. So over here, they're naming them with different letters so we don't get confused. We're not going to say this is graph 1, graph 2, graph 3. This is why they introduce function notation, and it's the f of x, the g of x, and the h of x. Now, notice on each one of these 3 functions, the only thing that's changed is the number that's in front of x squared. So what they've done is they've rewritten it. Notice there's no b term or no c term, and that's okay. You don't need a b or a c term for it to be quadratic. All you need is an a term. So now that they've rewritten this, and now what we're going to do is we're going to compare those numbers. So the number that's going to be in front of a, it's going to give us a lot of information. Remember, we've already learned that when a was negative, we knew that it was facing downward. When a was positive, it was facing upward. Now, the number in front of a is also going to tell us how wide our parabola is. And they've actually graphed the three functions. So we have the f of x equals x squared. The red one is our parent. Then notice what happens when the number in front of x squared gets smaller. What happened to our graph from red to green? Did it get narrower or did it get wider? It got wider. So as your number in front of x squared gets smaller, it gets wider. So you would sort of think backwards, that maybe when the number got smaller, it got skinnier. But instead, when the number gets smaller, it gets wider. Now, also when you're looking at the numbers in front of x squared, we're going to take the absolute value of it. Because if you think about it and you look at the blue one, see how the number's -3? And you think that's smaller, right? Because it's a negative number. But what we're doing is we're not looking at the negative sign, we're just looking at the number itself. Because the negative sign tells me it's facing downward. The 3 is going to tell me how narrow or wide the graph is. So what we're going to do is we're going to take the absolute value. So my advice to you is when you're comparing the widths, if you want to order them from narrowest to widest, what you should do is just order the numbers from greatest to least. Okay, but don't look at the sign. So like you would put -3 first, then the 1/2, and then the 1, which is in front of the x squared. This would give you the order of your graphs from narrowest to widest. Again, you're thinking absolute value here. So you're just thinking about the 3 when we're ordering for the width of the graph. Yes?
Wait, wouldn't the 1 and the 1/2 be switched because the 1/2 is wider than the 1?
Yes, thank you. Sorry. I wrote that backwards. Good. Okay, so I need to switch these. And it is the 1 first, then the 1/2. So from greatest to least, based on that coefficient in front of A, so you're going to do the 3 first, then the 1, then the 1/2. The 1/2 is going to be the widest graph here. And you can see that in the picture that the green is the widest graph out of the red, blue, and green. Let's look at some more examples.
Question?
Yes?
The bigger the number, the more wider it's going to be?
No, the bigger the number, the skinnier it's going to be, or the narrower. So the smaller the number, the wider it's going to be. So it's sort of backwards of what you would naturally think. Yes?
Why is -3 smaller?
Because what you're going to do is you have to take the absolute value of -3. So for example, on this one, notice the green is -2. I'm going to absolute value it and make it +2. Then the red one is 1. I absolute value it, it's +1. And then the blue is 1/4. If I absolute value 1/4, it becomes positive. And now if you take your numbers and you order them from greatest to least, now your graphs, or the colors of the graph, are going to be from narrowest to widest. So the g of x will be the narrowest graph. because it has the largest coefficient after it's been absolute valued. Then you would do, next would be the red, which is the parent. And then lastly, the h of x, which has the smallest a value. So the smaller the number in front of x squared, the wider it is. And again, don't look at the negative sign. The negative sign tells you up or down. It doesn't give the value. Does that make sense? Okay, because I could have two graphs. I could have f of x equals 2x squared and g of x equaling negative 2x squared. These are both going to have the same width, but what will be different is this one will be up and this one will be down. But they will both of them will have the same width. Does that make sense? All right. Here's another one. Now, on the test next week, you will be ordering these from either narrowest to widest or widest to narrowest. So when you're taking the test next week, make sure you're paying attention to the order that I want them. Now, what's going to be tricky here is the test next week is multiple choice, and they're going to have it both ways. So it's going to be important that you're paying attention to the little details. So for this one, when I'm comparing a 3 and a 0.5, again, I'm going to absolute value it. They're both positive, so it's really not changing anything. And then I'm going to order them from narrowest to the greatest. So the narrowest graph is going to be the biggest number. So I could see that the f of x will be the narrowest, and then the g of x will be the next one bigger. Is that making sense? So the bigger the number, the narrower it is, the more narrow. So here is a simulation with a graphing calculator. So in Algebra 2, if you happen to purchase a graphing calculator, this is how it would look on your graphing calculator on your display. They do have newer ones that have a color display, and it will show your graph in color and say the f of x might be blue and the g of x might be red, whatever colors you set up. So the newer technology is really nice. Okay, so here's another example. Let's go ahead and let's find the absolute value of each one of these. So we have f of x. This is our parent. Remember, there's an assumed 1 here. Then we have the g of x, and it's got 1/2. And then we have the h of x, and it's got negative 2x squared. I need to absolute value each one of these and figure out what numbers I'm using to compare. Again, remember on this h of x here, this negative 2, or the negative sign, is going to indicate that my graph is looking like this. It's facing down. Okay, so now in order to put them in order from narrowest to widest, which one will go first? The green, the blue, or the red?
Green.
The green, because it's the biggest number. So the narrowest one is the biggest number, which is the 2. So my most narrow function here is going to be the h of x. Then the next biggest number will be the red, which is the parent. And then lastly, the blue, because it's the smallest number in front of x squared. Yes?
What do you mean by parent?
The parent is usually the main function that you're going to compare everything to. So it's basically just the variable. There's no number in front. There's no y-intercept. It's just going to start at 0, 0. It's going to have an axis of symmetry of x equals 0. And then everything that we can compare to it when we add in more numbers to the equation. So it's the main one that you compare to. So they talk about a family of functions, and that would be things that have similar characteristics. Okay, so here they've done it for us. They've given us a visual And you can see that what we just stated, that h of x is the narrowest, and then the parent is the middle one, and then the widest one is the one with the 1/2. Again, here's another one. Again, remember there's an assumed 1 here in front of this one, but you're absolute valuing it, so then it becomes positive 1. So then we're comparing the numbers 1 and then the fraction 2/3. And if we order them from greatest to least, then we can see that the narrowest one will be the f of x, and then the g of x would be next. Your brain's gonna make you think, wait a minute, the bigger the number, the wider it is, but you gotta think backwards. The larger the absolute value number is, the more narrow it is.
Think of rise over 1.
To help you with this? Okay.
Rise over 1.
Let's look at another example. Okay, here we have, again, 3 functions to compare. Again, we could say this is the red one, and the absolute value is 4. Then this could be the blue one, and we have a 6. And then we have a green, and it's right here. So now if we order the numbers from greatest to least, then it's automatically in order from narrowest to widest. So the g of x would be the most narrow, then the f of x, and then the widest would be the h of x. And here is the visual using the graphing technology. Okay, so up to this point, all we were looking at was the number in front of x squared. Now we're going to look at the c in our equation, because remember, standard form is ax squared, write it here in black, ax squared plus bx plus c. So up to this point, all we were focusing on was this a, which was the number in front of x squared. So again, remember, when a is negative, it's facing downward. When a is positive, it was upward. And then remember, the larger the a, the more narrow the graph. Yes?
Do we have to do the graph that says same or different?
What do you mean?
Like the one that is right here, do we have to do that graph, or is it just the same or different graph?
This is just asking you what we're going to be looking at.
Oh.
Okay? So what they're telling us to do here is when the a term is 1 and there isn't a b term, the value of c is going to tell us how the graph is going to move now. So what we're going to do now is we're going to focus on this last number. And just like before when we did the linear functions, this c, remember, is our y-intercept. So this is going to tell us how the graph slides, up or down. So when the c is positive, it's going to slide up. When the c is negative, it's going to be sliding down. So let's go ahead and take a look at that.
I thought the a to x that Tristan said it's going to be a problem, like so.
Yeah, well, the a in front of the x squared, this is the number in front of x squared. When this is negative, it's going to be downward. It's going to look like this. When a is positive, it's upward.
And then what about the c?
The c, for example, if, and actually I'll zoom into this. So notice this one, the red one, there's no c. It's 0, right? So right here, it's hitting the y-axis at 0. But then as soon as I change the c, so right now the red was x squared plus nothing. So as soon as, to the green one, as soon as I change that and put a -4, it's sliding it down.
Yeah, I understand.
Okay? So it's moving the vertex down here to -4. Notice in the blue one, it changed to +3. So from red to blue, this shifted up 3 units. So the C is going to tell us where it's hitting the y-axis. And if it's a positive or a plus C, or a positive C, it's going to shift it up. If it's a negative C, it's going to shift it down. Okay, so here, the value of C is making each one of those graphs look different. Okay, the value of C determines not only the value of the y-intercept, but it's also going to tell us up or down. So again, when C is positive, it's going up. When C is negative, it's going to go down. Sort of like with the A. Remember when A was positive, it was upward. When A was negative, it was downward. So the negative and the positive still tell you the same direction. It's just doing something differently to our graph. So again, here it is, the vertical translation. So when I translate something vertically, what I'm doing is if my original parabola was right here at 0, 0, and if I changed my y-intercept or my C, so again, if the parent was f of x equals x squared, and then the g of x was x squared plus 5, I know I might be somewhere up here. But if my h of x were -2, then I know my graph would be down here. So this number that's after the x squared is going to tell us how it's shifting. And it's usually compared to the red one, which is starting at the 0. Okay, again, when you're comparing these graphs, sometimes it's a good idea to graph them. We saw this with the linear functions, and it'll give you a visual of what's happening to your graph. So here, they want us to compare. So now, on the test next week, you're going to have to order them from narrowest to widest. You're also going to have to compare them and tell me what changed. So notice on this one, and again, we can just look at the equations. Again, they're recommending that you graph them for even a better visual. So I'm going to write my equations here side by side. Now, let's go ahead and first look at the A. So notice the A in front of this one is a 1. And my A in front of this one is -1/4. So right away, one description that I can give is one's positive, one's negative. So one change is the graph f of x opens upward, where graph g of x opens downward. So you could say f of x opens upward because it's positive, and g of x is downward. We can also state that f of x, because it's a 1, is wider than the blue one. So this one's wider.
Teachers and students, part of the eruption, but Dylan Tarango, please report to student services. Dylan Tarango, please report to student services. Thank you.
The next thing we looked at was the size of the number. So we were comparing 1 to 1/4. And let me write this in blue. So because 1 was bigger, this told me, I'm sorry, I said that backwards. This is narrower. So the g of x, I can't erase. Okay. So the g of x is wider than the f of x. All right, so this one is wider because the 1/4 is the smaller number. Okay, this one is more narrow. The next thing we're going to look at is the c. Notice this one has +0. This one has +3. So this is telling me that the blue graph, or the g of x, is going to slide or translate up 3 units. So because of the +3, it's translated up from the red one 3 units. Yes?
The number right next to x2 is going to be the width?
Yes. So the smaller the number, the wider it is. So this one is wider. Look at another example. For the C?
Yeah.
Okay. Then it's not going to slide up or down. So if we were to compare x squared and 1/4 x squared with no c, this change would only be up and down, the upward and downward direction, and it would only be wider to narrower. Does that make sense? This one wouldn't be. This one would not have a translation. So no translation if these were the two equations. So when there's not a c, it's not sliding. The only thing that's going to change here is the direction and the width on these. Yes.
If it's 0, does it stay the same?
For which number? Let's try another example. All right, I'm going to compare f of x to g of x. First of all, does it change direction? Are they both the same sign, or are they different signs?
Same sign.
Same sign, right? So they're both facing upward. Everybody good on that part? Because the A is positive on both. Now, let's compare the numbers. So the red one is 1 and the blue one is 3. And again, you're absolute valuing these, but they're already both positive, so it doesn't really matter. So which one is the more narrow graph? Red or blue? Blue. Okay, this one is more narrow because it's a bigger number. So this one's narrower. And this one's wider. There is no y-intercept. It's 0 on, or there is a y-intercept, it's 0, because there's nothing being added here and nothing being added here. So the only thing that's changing here is the width of the graph. It's not changing direction, and it did not translate.
X2 as this, I know that's not the best example, but this one has a vertex of 0, 0, and this one has a vertex of 0, 10.
No, they're both 0, 0.
I know, but for different example, we should mention that too.
Yes.
And we should mention that both of the vertex x starts at 0, 0.
Yes.
We should
Okay.
mention that too.
Yes. Okay. You should also mention where the vertex is located, and you're going to use the formula just like you did on the quiz yesterday. First do the axis of symmetry and then plug it back in. Okay? Because on the multiple choice test next week, all of these characteristics are going to be listed. They're going to ask you the direction. They're going to ask you about the width. They're going to ask you the location of the vertex and the axis of symmetry. So be able to identify all of these things when you're comparing the graph.
And for the
I'm sorry?
three, you mentioned
And here is the visual. Here, they're asking us to compare another one. Notice all the things that they're discussing here. These are all going to be included in your answer. You're going to have to read through a lot of information in the multiple choice answers. This question is going to be very tricky. You must confirm that it satisfies all of the characteristics. So notice here, they're talking about the direction. Notice this one is positive and this one's negative. So this is why the graphs change direction. Then the next thing they're going to talk about is the axis of symmetry. And you're going to do the negative b over 2a to figure out. And in this one, both axes of symmetries are the same. Then you're also going to look for the vertex. Again, get the x first, then plug it in to get the y. Notice this one has a vertex, the red one, of 0, 0. But the blue one has a vertex of 0, -4. So you would compare and state the change in the vertex. Notice the number in front of both of the x squared terms is the same after you absolute value it. So the width did not change. Here's another example. Again, they're both opening upward, they're both positive. You're going to find the axis of symmetry first. Again, it's the same. But what's changing here is the location of the vertex, telling you it's a translation. And then again, we're going to see that because these numbers in front of x squared are different, the width is going to change. And here's another comparison with the visual. I'm going to get there. Okay. Everybody good on the comparisons? Make sure you're covering everything that's changing in your graph. All right, let's look at the word problem here. It says the quadratic function h of t, where this t is going to be the time in seconds. -16t squared plus c can be used to approximate the height h in feet above the ground of a falling object t seconds after it's dropped from a height of c feet. This model is used only to approximate the height of the falling objects because it does not account for air resistance, wind, or other real-world factors. Now, if you happen to take physics later on, these would be the types of equations you're going to use, but you're also going to take into consideration the wind or whatever's happening in the environment at that time. So this is assuming that everything's nice and calm, nothing's resisting this object from falling, nothing's blowing it in another direction, and this would be the equation you would use to approximate the height of this object when it falls from up in the air. So here it says you have two identical softballs. The first is dropped from a height of 400 feet and the second from 324. It wants us to write the two height functions and compare their graphs. So notice this c is the height that they're dropping it from. Okay, the number here is the same. So they want us to compare the difference in these two graphs. So here, maybe you're up on top of the roof and you're throwing the softballs off. So it's simulating what happens to the softball. So they used a graphing calculator. And because the time and the height can't be negative, this is why they're only showing the upper quadrant. So they're really only talking about up here. Okay, and then they're just going to plug in numbers to get the. When you are answering these questions in the homework tonight, you're going to plug in values for the time. You can plug in 1, 2, 3, plug in enough numbers to get a nice graph. so you can graph both equations on the same coordinate plane. So we're going to use the graph to tell us when the softball reaches the ground. And you would plug it in. Here's another one with 2 tennis balls that you're dropping from a height of 16 feet and 100 feet. And again, you're going to plug in values for t, create your graphs, and find out the height that it was. And then again, this is just a quick review. You're ordering the functions from narrowest to widest and giving all the comparisons of the two graphs.
Oh, so you're starting the lesson.